All right, folks, we continue with some Chapter 3 homework problems. Here goes. Jason Bourne is escaping across a rooftop and runs off the roof horizontally at a speed of 5.3 meters per second, hoping to land on the roof of an adjacent building. The horizontal distance between the two buildings is d. The adjacent building is 2 meters below the jumping off point. What is the maximum distance the two buildings can be apart in order for Jason to make the jump? We see this happen in all sorts of action movies where the hero is jumping between buildings all the time. So here's what's going on. We have a building. We have another building. There is 2 meters is the distance, the vertical displacement between these two. We have a superhero that's going to be going between the two, and he has a velocity of 5.3 meters per second, which is not terribly fast. We want to know how far apart can these two buildings be and not have Jason Bourne fall to a sad crash at the bottom. Okay. As always, horizontal stuff, vertical stuff, what do we know? Well, the 5.3, that's my horizontal velocity. That's how fast he's going to be jumping across. We know the vertical displacement is going to be the 2 meters. What else do we know? This is a straight horizontal projectile. He could, if he could jump up, he could give himself a little bit more velocity, but he's horizontally running at 5.3 meters per second. So it doesn't say anything about a jump. So original vertical velocity in this situation is going to be 0. Gravity is going to pull him downward at 9.8 meters per second squared. We can use this stuff to find the time that he's in the air. Once we know that, we can plug the time in on this side. And once we know that, we can figure out how far he's going to jump. And yeah, I know, the computer did that, didn't it? Let's hold on for another 5 seconds, and I can sing to you. You don't want me to sing. While it's taking its sweet time, coming back. There it is. It does usually, but sometimes it has a mood. Your computer gets moody sometimes, doesn't it? Yeah, once in a while. Okay, horizontal velocity is then going to be x over t. So what's our old friend over here, the drop equation? Y is VOT plus 1/2 AT squared. What have we got going on here? Original velocity is going to be 0. That's going to go down to 0. So y is going to be 1/2 AT squared, or time is going to be 2 times y divided by a square root. I'm getting nervous about with my computer whether I even want to try and give myself more room to write because it's being a little wackadoodle. All right, so 2 times the 2 meter drop, because that's my vertical displacement, divided by 9.8 square root. How long is he going to be in the air? That is not right, because I got a weird number. Square root that little beastie, I got 0.639 seconds that he's going to be airborne. I can plug that in over here, and then x is going to be, let's make it a little more visibly seeable, horizontal velocity times time. Horizontal velocity, I think for good old Jason, was 5.3 meters per second times 0.639 seconds. So multiply that by 5.3, and I get the horizontal distance between the buildings of 3.39 meters is the minimum distance. If it's further away from that, poor Jason's going to be a little puddle at the bottom and being sad and have to go off and see the doctor. All right, that should do it, and we will see you next time. Bye-bye.